Good evening, Internet. I am Matt Booyak, and tonight I'll be solving the 8th problem from the Project Euler problem archive. So this problem is pretty straightforward. We're given a 1,000-digit number, and we're asked to find the 13 adjacent digits which have the greatest product. And we're given this example input of 4 adjacent digits that have this product. So I think really the only thing to be aware of in approaching this problem is that we may not be able to store our 13-digit product, or product of 13 digits rather, in a 32-bit integer. And in fact, we can calculate this in a pretty straightforward way. So in the extreme case, we might have 13 adjacent 9s. Just scanning through the number, it doesn't appear that that's the case. But just to be sure, let's see what that would come out to. So if we had 13 adjacent 9s, we would have this number roughly 2.5 trillion. And a formula that's useful to know is that if we want to know the number of bits required to store a number, if you take that number and you add 1, and then you take log base 2 of that number, and then take the ceiling of that, that will be the number of bits that are required. So if we have this number, we add 1. This calculator doesn't have a log function with an arbitrary base, but it's easy to calculate that just by, we can use common log, and then divided by log base 10 of 2. And so that gives us 41.2 and change, and we round that up to 42 bits. So this won't fit in a 32-bit integer, but it will fit comfortably in a 64-bit integer. So we should be good to go as long as we're aware of that. So let's go over to our terminal here. Open up a shell. And let's see, let's copy our template directory to make our problem directory. And let's open up our main.cpp. Let me just make sure that you can see my terminal here. Okay, and I think we're ready to go. Let's copy our number here over into the terminal. So we'll just say const char number, and there we go. Okay, so let's see, it'll be just a little bit tedious to do this. So if this number were much larger, there's some command line utilities that I could use to speed this up, but it's not really so lengthy as to warrant such methods. Okay, so one thing to be aware of is that C and C++, if you have 2 strings with only white space between them, that is exactly the same as if you have just a single large string. And so we don't have to worry about joining this all onto one line or combining our strings somehow in software. Yeah. Yeah, that should be good. Okay, so moving down to our program proper, we'll need to keep track of our current index. So what character are we looking at? We'll need to keep track of our current product. We'll need to keep track of the largest product that we've seen so far. And we probably want to define a constant just to indicate the number of characters in our product. And the reason I'm doing that is because the example input is a product of 4 characters. Eventually we'll need to ramp that up to 13 characters, but we want to be able to double check our program against the example input. Let's see. Let me just, I'm assuming that this is in 20 lines of 50 here, but let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yes, that's, so we're gonna say, should be 1001. So remember that in C and C++, a string needs 1 extra byte for the terminating character. So if we have a 1,000 digit number, then we need 1001 bytes in order to store that. Okay, so let's begin by calculating our initial current product. And so we'll say for I is equal to 0, I is less than prodlen increment I. Let's say cur prod equals 1, and then we'll say let's see here, cur prod times equals so one thing to keep in mind is that this is not an integer, this is a string. And so each of these characters appears in memory as not, so for example, this 9 that I have highlighted doesn't appear as a 9 in memory. There's an encoding of common characters, ASCII. Let me just, or usually pronounced ASCII. Yeah, and you can see the table here. And so for example, if you want the character, let's see here, where are the digits? So like here, the 9 that I was talking about is actually going to be the value 57 in memory. And so we can't use that directly. We have to convert from that code into that value. And so the way that we do that, fortunately, C and C++, it's easy to do that conversion because, for example, if I use this character here, this is the equivalent to the code for 0. So so that would have the value 48. And so then, and as you can see, all of the digits are consecutive in the encoding, and likewise with the alphabetic characters. And so it's easy to convert just by doing subtraction. So we can do, let's see, what did I name my, oh, it was just number, okay. So just by doing number I minus 0, that's going to give us the actual numeric value of that digit. So there's a trick that I was planning on using, but it actually comes with a there's a bit of a trap. So there's a trick you can do where if suppose I multiply the first 4 characters here, and then I want to find the product of the 2nd through 5th character. Then what I can do is I can take my product and divide by 7. So that'll give me just the product of that 3 times 1 times 6. And then multiply by 7. And that'll give me the new product of 3, 1, 6, and 7. And that works for, even if I had 100 digits that I was multiplying together. If I had digits 0 through 99 multiplied together, and then I want to find the product of digits 1 through 100, I just divide by digit 0, multiply by digit 100, and I'm good to go. The gotcha is that you can't divide by 0. And so that trick won't actually work. And so I think we're actually better off just doing it the naive way. And so what we'll do then is, let's see, we'll just, we'll say for I equals 0, and then I plus prodlen, let's see here. So one thing I'm trying to think through is if we want less than or equal to here. So let's suppose our prodlen was 4, and then our buffer was only 4 elements. And so in that case, we would have I would be 0, prodlen would be 4, and then our upper bound would be 4. So we do want this to be less than or equal to, because otherwise we wouldn't even try that single case in the example I just described. Let's, as I've mentioned in the past, we don't like hard-coded constants because they can always change. If suppose suddenly we have a larger buffer or a larger number that we want to use as our input. So we'll just say const size t, or we'll call it number length equals 1,000, and then we'll say number length plus 1. So one advantage of including the size here, it's actually not required, but it guarantees that the contents that you've specified here actually match what you've put in here. If you put too many characters down here for the size that you have up here, then the compiler will warn you. So I could just leave this blank, but then that's one less opportunity to catch a mistake. So we're gonna put that in there. Okay, so now we'll iterate number length. Yeah, it should be good. And then for each one, we're going to say curprod equals 1. For j is 0j less than prodlen plus j. And then we'll have curprod times equals, so that's equivalent to saying curprod times curprod, or equals curprod times, we're going to say number I minus 0. Let me just get rid of this extra stuff that I had added down there. Okay, let's initialize our max product to 0, because in the worst case scenario, we have every section of length prod len contains 0, in which case maybe our answer would be 0. And so that's going to be the minimum. That's a lower bound on what our answer can be. So we're going to start off there, and then after we've calculated cur prod, we're going to say if cur prod is greater than max prod equals cur prod. Yeah, I think that all looks good to me. Let's see what we've got. Okay, so here we get 6,561. So go back here. That's not correct. That's very surprising. This problem is not. Oh, I see. I was going to say it's not a particularly lengthy or complicated problem, but I see the mistake that we've made now. We need this should be plus j. I believe that's correct. There we go. Okay, so that gives us some confidence to try this with our 13 digits. And actually, just as an extra sanity check, one thing we can do is we can say uint32t max lock. So that's max location, and so we'll just say max lock equals I, and then max lock equals okay. So all right, so as I mentioned, I think each of these has 50 characters or digits in each row, and so that would be I believe in the 13th, so 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, and then it's going to be yes, I can see it here, 9, 9, 8, 9. So if we just look at this, would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. So that does match our expectations, 9, 9, 8, 9. Okay, so now we can try this ramping our product length up to 13. Okay, so we have our number there, and if we wanted to, we could. I suppose we can still do the same sanity check here. I believe that would be in the third row here. Excuse me, the let me think through this. So this is going to be 0 through 49, 50 through 99, 100 through 149, 150 through 199. So that's 199, 8, 7. Okay, so we can calculate this by hand just to verify that it matches what we expect. So I think that was, let's see, 5 times 7 times, let's see, 668966. Yes, and I believe that matches our calculated value. So that gives us a little bit more confidence that, that we have the correct answer. And we can see that it does indeed match our expectations. So that's it for problem 8. We'll continue in the next video with problem number 9.